Hello students, welcome once again to Soros's classes. So today we will continue our video on limits chapter. We were already doing this chapter limits, and in the previous part I had explained how a function exists, f of a exists, but the limit x tends to a, f of x doesn't exist. Right. Now after this we are going to continue with the next part of it. The next part will be example number 4 most probably. Okay, you write it numbering wise. It says that limit of x tends to a, f of x and f of a exists but are not equal. Okay, so let's give an example for this. So the example would be the same. Let's say if I take the function f of x is equal to x square minus 4 by x minus 2 when x is not equal to 2, and it's going to be 3 when x is equal to 2. So we're going to check. So look over here, x tends to a. So limit, let's check the LHL, left hand limit. Limit x tends to 2 positive, left hand limit, let's just change that to r. F of x is equal to limit x tends to 2 positive. So which one are we going to take? 2 positive means not equal to 2. So we are going to take the above function. So that will be x square minus 4 by x minus 2. Okay, so that is limit x tends to 2, x plus 2. Okay, so from here what do we get? We get limit, no more limit over here anymore. Answer is 2. So limit x tends to 2 positive, f of x. Okay, that implies that limit x tends to 2 negative, f of x is again 2. So in general, limit x tends to 2, f of x is 2. But what is f of 2? Is 3. Right. So we can see f of 2 is 3. You can see over here f of 2 is given as 3. Okay, so what does it mean? That means this limit x tends to 2, f of x is not equal to f of 2. So this is what I was trying to show you. Sometimes this will also happen. Okay, now the next type will be that the limit and both of them are existing and also equal. Okay, so the next one will be, let's just scroll down a little bit more. So it's going to be example number 5 most probably. So limit x tends to a, f of x and f of a exists and are equal to each other. So let's give you an example, similar type. We'll try and confine ourselves to similar examples so that you can understand better. So x square minus 4, x minus 2 when x is not equal to 2, and of course it becomes 4 when x is equal to 2. Now let's try and find the limit. So we'll find directly the general limit over here. Okay, so limit x tends to 2 f of x is equal to limit x tends to 2 x square minus 4 x minus 2. Now you must be wondering that it's saying limit of x tends to 2. So if it's x tends to 2, then why is sir taking this function? Because x tends to 2 means this function, right? But no, x tends to 2 means not equal to 2. Understood? Okay, so that means we will have to take this function. We will have to take this one. So eventually what does this become? This becomes 4. Okay, limit, you can put the value and check f of x. How will become 4? Split this part, x plus 2, x minus 2, x minus 2 and x minus 2 will get cancelled out and then become 4. Okay, now what is f of a? F of 2, that is 4. So basically this is what we had to prove. Limit of x tends to a, f of x is equal to f of a. Okay, so that is equal. In the previous part it was not equal, but in this part it is equal. So if we are to write in the context of this question, then we will write limit x tends to 2 f of x is equal to f of 2. Okay, this is in the context of this question. Okay, otherwise you will write x tends to a. Okay, so this is also done. So this part is also done. Now there are basic theorems or a few formulae on limits, okay, which you have studied in class 11 also. Okay, so I'm going to give you a few formulae, so you might want to write these down or note these down somewhere. So the first one would be this. First one, limit x tends to a bracket c f of x. What is c? The c is a constant, can be written as c limit x tends to a f of x. Okay, alright, let's go on to the second one. Alright, the second one would be, let's give it in point wise only properly. Alright, the second one will be that a limit x tends to a f of x plus g of x, and two functions are added. There will be limit x tends to a f of x plus limit x tends to a g of x. Very small things you have already studied in your junior classes. Okay, but since we are doing the whole real analysis, so we need to understand the limit chapter and everything in it. Okay, so next one, limit x tends to a f of x minus g of x is equal to limit x tends to a f of x minus, just hold on, minus limit x tends to a g of x. Next one, fourth one, limit x tends to a f of x dot g of x. Dot means multiplication. So this becomes limit x tends to a f of x dot limit x tends to a g of x. What is happening? The limit is actually getting distributed. Okay, the fifth one will be limit x tends to a f of x divided by g of x will give you limit x tends to a f of x divided by limit x tends to a g of x. Okay, so these are all simple, very simple theorems given to you. All right, and formula, actually theorems, formula, anything. The sixth one will be this. The sixth one will be limit x tends to a f of x is less than equal to limit x tends to a g of x if f of x is less than equal to g of x. Alright, so this was till the formulae part. Okay, so in this video, what did we learn? What did we learn from this part in this video? Let's go back. So we learned that how when limit x tends to a f of x and f of a both are existing means both are having values. Okay, but the problem is they are not equal. So over here you will notice that they are not equal is the main thing that you should emphasize on. Is both the limit and the function at the given point or at the indicated points are existing, but are definitely not equal to each other. So for on this you can see the example given to you where f of x is this whole function. When x is not equal to 2, then this will happen, and when x is equal to 2, then it will be 3. So when I'm finding the result, when I'm finding the RHL and LHL, I'm seeing that in general it's coming as 2. The limit of the function is coming as 2. But what about the function? What about the function? What about the function is coming 3. Function is coming 3. So what is happening? Happening that it's not coming equal, right? It is not equal to each other. The limit of the function and the function at the indicated points are not equal to each other. Now, in example number 5, what did we learn? In example number 5, we have learned that the limit of f of x and the function at a does exist, okay, but are also equal to each other. Okay, so here it is. Here is the thing that I have showed you. So here you can see that the limit of the function is existing. It's coming as 4, right? This part. But what you need to concentrate, I'm highlighting in the examples when you are going through the notes. Okay, but the function at 2 is 4. Hence, it satisfies the condition that limit x tends to a f of x is equal to the given function at a. Alright, so in this context, in the context of this question, you will be definitely using this one, okay, but in general you are not going to use that. You are actually trying to prove this. You are actually trying to prove this part. Alright, this part. Okay, next, the different types of formulae are given to us. First one, limit x tends to a. If it is multiplied, the function is multiplied with a constant value, then the constant comes out and you do the normal limit over here. The constant comes out and you do the normal limit of the function. Then if the two different functions are added, then the limit is split for the function. Limit is distributed, what I mean to say. Next, if the limit is subtracted for two functions, then again the limit is distributed, as you can see here. Okay, let's go on to the next one. When it's multiplied, when two functions are multiplied, the similar thing will happen. Limit will be distributed, okay, and the functions will be multiplied and the limit will be distributed. Okay, now the fifth one, when they are divided, same way, limit will be distributed. Okay, you see over here clearly that the limit is getting distributed. Alright, in the sixth one, what is happening? In the sixth one, the limit of one function will be less than equal to the limit of the other, and that will only happen if one function is less than equal to the other. Okay, this condition is only applicable when this condition is satisfied. Okay, so that's it for this video, students. I will continue limits in the next video, so keep taking enough help from Saurav sir's classes, because always the help that you need is provided at Saurav sir's classes. Thank you for watching.